Hi, Year 12. Welcome to my second lesson on atomic structure. This lesson we're going to be looking at mass number, A, and atomic number, or the proton number, Z. Okay, kind of revision of GCSE, but also a little bit more depth. You're going to learn how to determine the number of fundamental particles in atoms and ions using mass number, atomic number, and charge. So that's like kind of filling in a table, similar to like a PEN table, like you might have done in GCSE, proton, electron, neutron table. But it can get a little bit more complicated when you've got ions, okay, and also isotopes as well. So we're going to look at isotopes a little bit more in a bit more detail and explain their existence. Okay, and also, I think you have in the past worked out how to calculate the weighted average mass of isotopes. We'll look at that as well. Okay, so atomic number Z. Yeah, it's given the symbol Z. And it's always related to the number of protons that something has, some element has. If you change the number of protons, then you're going to change the element, totally different element. Okay, so Z's are really quite an important number. And it can only be changed by nuclear reactions. Okay, the atomic mass is given the symbol A, and that's the sum of the nucleons. Remember, the nucleons are the things in the nucleus. That's the protons and the neutrons. Okay. If you use a really accurate periodic table, you see that it's sometimes down to 4 decimal places, and that's to do with the mass defect that we looked at previously, but also to do with averages that come about from isotopes, yeah, because you can have a variety of different isotopes. So the overall atomic mass is an average of all those isotopes. Okay, so it doesn't matter which way around it is, but the bigger numbers, because sometimes the bigger numbers at the bottom. But the bigger number is always the mass number, and the smaller number is always the atomic number. The periodic table currently is arranged in sequence of atomic number, yeah, but it wasn't always thus. It was previously, before Mendeleev kind of figured out things on a deeper level with the periodic table. Dmitry Mendeleev, who was a Russian scientist, then it was actually ordered in terms of mass. And that was one of the hindrances to discovering what Mendeleev ended up discovering, because everyone thought it was ordered in terms of mass, which is not true. Okay, so let's look at the second point there. Determine the number of fundamental particles. This is a skill you're going to have to learn in atoms and ions using the mass number, the atomic number, and the charge. Okay, so looking at this table, I want you guys to fill this out. Okay, you should be able to do it. Fairly straightforward. So for A, let's have a look at A. You've got 19 protons, you've got 21 neutrons, and you've got 19 electrons. Protons and electrons are balanced, so there can't be a charge. The atomic number is the same as the number of protons, which is 19. The mass number must be the sum of the nucleons, which is the neutrons and the protons. 19 plus 21 gives 40, and that gives you the symbol of potassium. Okay, I'll let you have a go at all of those by yourself. Okay, so now let's take a look at isotopes. So as we've said before, the protons defines the element, okay, but the neutrons, so you can't really play with the protons when you're talking about one element, okay, but you can change the number of neutrons, okay, and when we change the number of neutrons, or when we find that there's a different number of neutrons, then it's an isotope of that element, okay. Isotopes vary in their abundance and their stability. So for example, carbon-14 is less stable than carbon-12. Okay, but most elements tend to have at least 2 isotopes that are stable. They're not like radioactive. They're not going to break apart within seconds or milliseconds. Might take a long time. Like, for example, carbon-14, I think it's around 4,000 years it takes to break down. Might have a very long half-life. But some of them are very, very short. Okay, tin, Sn is the symbol of tin because its old name was stannum in Latin. Has the most stable isotopes. It's got 10, which is quite a few. So another isotope of carbon is carbon 13, okay? And carbon 12, 13, and 14 are all fairly stable, but you can see that their mass numbers are different straight off, okay? But the atomic numbers are the same. So clearly, you can subtract the two to find the number of neutrons. We've got 6 neutrons here, and here we've got 7. Okay, here we would have 8 neutrons. You can count them if you want, the white ones. I'll let you have a look for 3 other common isotopes you may have heard of. Okay, and finally for this lesson, I want you guys to work through at least the top 2 of these activities. Okay, you're going to have to go to PhET and log in, register with them, which you should be able to do using, just use your school email and password to create an account. And then do these first 2 at least. Okay, if you want, go on and do other ones, but at least the first 2 for homework. It should be fairly straightforward. Yeah. If you do get stuck, send me a message. And that's it for this lesson.